When you're running a globally distributed API service that has over 1 billion devices connected, every single millisecond counts. And what we did last week, we released a new service in production that reduced our overall write latency in our data pipeline by quite a few milliseconds, not just like 1 or 2, but by 4 times reduction. We reduced our write latency. It's a huge jump from 120 milliseconds down all the way to 30 milliseconds. This is huge. It's an amazing benefit for every device that's connected. This is our write data pipeline that we replaced with a new Rust-based service. This is our infrastructure achievement that we are really excited to share. It's a significant gain. I mean, just check out the performance difference you see here in the chart that we were averaging around here, in the 130 millisecond zone, 120 milliseconds. And then we click the deploy button. You see the deploy button here, yep, and that purple line, another deploy button here in another zone, and another zone, another zone. And since we deployed it in every zone globally, you can see all of them dropping down. It's so cool. Look at that. And that's all through the power of Rust. So we had previously a C-based library that was being accessed by a Python application. And even with the power of those combinations, we still had significant overhead from that layer. And by switching to 100% pure Rust implementation, this means that we gain these benefits. And it's a huge switch. And so our data pipeline now has been a critical component for our real-time infrastructure because it handles copying all the events over to multiple different systems that do things like they track presence detection, they store data for measuring and monitoring and analytics, they do data processing and even store data for retrieval through indexing systems and engines. There's just a lot of stuff that goes on, and this is a huge win because it affects basically every single API call on the network. The results really do speak for themselves. As we deployed last week a new Rust service into our infrastructure, we saw a significant drop in our latency, which is fantastic. We're looking here at an average of around 120 milliseconds. It goes up to 140 we see here, and it drops all the way down to this significantly lower level, right around 30 milliseconds. And that's huge. It's consistent. So we see here that Cody Carlsen says he loves how consistently powerful Rust is. This is totally true. This is absolutely true for us. We've seen it not only in the data charts for this new service that we deployed, but every time we deploy a new service with Rust, we see similar outcomes. And it's amazing. Cody Carlsen was the one who led the development of this most recent update, and we've seen significant gains of it. It is a massive win, and it's really big because now it's a significant boost in performance for all our APIs and our customers, but it's also a nice cost reduction as well. It improves the user experience, and it allows us to scale better so we can service the API with even more data and more volume. It's amazing. Because of the significant wins we've seen with deploying services in production that are written in Rust, we are going to continue to deploy Rust applications at scale. We've done this multiple times now, and the charts, they are just amazing, right? So we were just looking at a chart over here where we saw a significant drop in latency, and the performance is huge. This is amazing. We love it because not only does it provide better user experiences for developers using our APIs, but at the same time, this is a significant reduction in overall operations burden that allows us to scale more easily and have a better utilization on the resources that we've purchased, right? So you need compute. We need compute. In order to run Rust applications, you have to purchase CPUs, and this has allowed us to optimally utilize the hardware that we've purchased. And it's huge. It's amazing. So now the plan is that we're still at the beginning, and we've deployed maybe around 5-6 different services in production with Rust. We're going to continue to do that because we've seen significant gains every single time. It's always amazing. A significant win and a reduction of the full utilization of the hardware that we purchase. And also, it's just so much faster, right? Even with 10x more hardware, we can't achieve the same performance levels with other types of technologies. And previously, we've had a combination of C and Python and Java, and it does not compare. Even Go, for example, it's just not quite at that level of Rust. And we've seen it multiple times. And what we're doing now is focusing as much of our efforts as we can on Rust going forward.